All right, 9.9, last one, solve problems with fractions and mixed numbers. So the goal is to be able to solve word problems with fractions. So I wanted to start by just reminding us like what each operation sort of means and how we see it. So with adding, we're talking about combining numbers. Now I hesitate to put keywords because keywords can be a little misleading, but some like more. Now granted, you can also see more over in subtraction, just in different phrases, like how much more. But like if I say, I have this much, I got this much more, how much do I have now? We're combining those two things. So that's, again, when I don't want to necessarily focus on the keywords, although those work, but I would rather you think about what this story actually means. So go ahead and write just sort of the meaning of the operations in your notes. With subtraction, either we are comparing, so how much more, how much less, how much taller, how much shorter, what's the difference, or we're taking away. So if someone has something and then it gets eaten, it gets sold, they spend the money, we're taking something away, so we know we're subtracting. These are the ones we'll see in our problems today. I wanted to add multiplying and dividing just as a review, but you won't actually see them on problems today since we're just talking about adding and subtracting fractions. It's a good clue on tests in 5th grade that you won't see problems where you have to multiply or divide fractions. So multiplying is we're combining, but we're combining equal groups, right? We've talked about how if I have something like 2 plus 2 plus 2 plus 2 plus 2 or whatever, I can just add all those together, or I can just do 2 times 5 since they're all equal. Dividing, we're splitting things up into equal groups. Now, sometimes I know how many groups there are. Sometimes I know how big each group is. But we are splitting into equal groups. Sorry for the messy handwriting on my screen. It gets a little tricky. All right, now we'll go do some practice problems. I just wanted to remind us of what they mean. So, Myra runs each day and records the distances. On Thursday, she ran 1 5/6 more miles than on Monday. Okay, so Thursday is comparing to Monday. On Friday, she ran 1.5 miles less than on Tuesday. Sorry, I just sneezed and it got stuck there for a second. So how many miles did Myra run on Thursday and Friday? So let's look at Thursday first. We can see, okay, on Thursday, she ran 1 5/6 more miles than on Monday. So we're taking Mondays, and she ran more than that. So we're taking this and we're adding it to this. So I thought about what it meant. She said, okay, this much. She took how much on Monday and then added more. So we are doing 2 2/3 plus 1 5/6. We're doing our same steps as always. I'm going to use 6 as my common denominator. So that's times 2. So I get 4/6. That one just stays the same. This is when if I add, I get an improper fraction. So I need to think, oh, that equals 1 3/6. Right? Because 6/6 is 1. I have 3 extra. Then I take my whole numbers. I add them together. So I get 4. 3/6. I could write 3/6, but if I divide by 3, that does simplify to 1/2. So, more practice with adding fractions, but also seeing that within another word problem. If she ran more miles, just think about it without the fractions if that helps. On Thursday, she ran 1 mile. On Monday, she ran 2 miles. On Thursday, she ran 1 more mile. Oh, I'm just adding those together. I'm just combining those amounts. So sometimes the fraction, it's like confuses your brain with the story. So if you simplify it and only use whole numbers, think about what it means, get the operation in your head. Oh, I'm adding. And then add the fractions. That can help. Because sometimes those fractions just make it harder to understand what operation we're doing. For example, we can say, okay, on Friday she ran, well, just imagine she ran 1 mile less than on Tuesday. So let's say on Tuesday she ran 4 miles. On Friday she ran 1 mile less. Oh, well, I'm just taking 4 minus 1. But actually, we're doing 4 3/5 minus 1 1/2. So that's where just thinking about the whole numbers, it might be more obvious to you that it's subtraction, and then you can put the fractions back in. So I'm going to use 10 and 10. This is times 2, so I get 6, times 5, so I get 5. This one I don't have to borrow. 6/10 minus 5/10 is just 1/10. 4 minus 1 is 3. So 3 1/10 on Friday is what we're doing for that one. So notice how I went back and reread it multiple times. I thought about what was happening. I thought about sort of what operation I was going to do. I thought about it without the fractions initially, and then I put the fractions back in. So all sorts of strategies we can use. All right, so when we did, now they do look at like decomposing, where you add the whole numbers, you add the fractions like we did, then they rewrote it. So it's essentially the same thing, but sometimes you will see it written out a little bit different. Like with this one, again, they changed them to improper. I get it if instead of regrouping, I don't necessarily get why we would do it here, if I'm being honest. All right. I'm going to have you try this. It's a little tricky, so if you're not sure, just guess and then I'll explain it. Yin was at the park for 5 hours. She spent 2 1/4 hours playing soccer. How long did she spend at the park not playing soccer? See if you can figure it out. Did you get it? All right, this requires a couple of different things. The first thing is thinking about what operation. So if we know she spent all this time at the park, 5 hours, 2 1/4 of it was playing at the park, right? Just making sure. Oh, sorry, playing soccer. So this was her soccer. And she spent the rest of it not playing soccer. So what's that missing part? Anytime we're trying to find a missing part, we need to subtract. So I'm going to do 5 minus 2 1/4. Now this is a very common thing where I'm like, I don't have a fraction here. How do I do no fraction minus 1/4? Well, let's think about how many fourths do I have? I have 0/4. Oh, now I can regroup. That turns into a 4. I add on 4/4. So now I really just have 4/4, right? So now I can subtract 1/4, get 3/4. 4 minus 2 is 2. So, weird problem, but if we have a whole number, that is one strategy we can use, is to think like, oh, the fraction is actually 0, however many's. Or you can think of it on a number line. If we start at 5, we're going down 2, right? So that's down to 3. Down another 4th. So like if this is a whole, I'm just going down a 4th. Oh, so I ended at 2 and 1, 2, 3/4. So because we're not having to rewrite our fractions at all, it can be a little simpler to think of it in terms of a number line. All right, let's do just 2 practice problems with this one. Because mostly we're just practicing figuring out what operation we are doing. Then it's also a little good practice with fractions. All right, Jonah walks 2 7/8 miles on Monday. On Tuesday, he walks 1 2/3 miles. How many miles does Jonah walk on Monday and Tuesday? Go ahead and give it a try. All right, hope you got it. I'll go over this quick. So we have 2 7/8 plus 1 2/3 right? Because we're adding. We have Monday and Tuesday. We're combining them. So 24th, 24. This is times 3, so 21. This is times 8, so 16. Now after I add them, I'm going to get 37 24ths. That's improper, so let's rewrite that. If I take away 24 24ths, I'm going to have 13 24ths. So I have that one whole and 13 24ths. Combined with my other whole numbers, I get 4 and 13 24ths. All right, let's do one more. Ayana buys 4 3/10 pounds of potatoes. She uses 2 3/4 pounds in a recipe. How many pounds does she have now? Give it a try. All right, hopefully you knew to subtract, because if she bought some and then she used it, we're taking that away to find out how many she has left. Even though it doesn't say how many does she have left, that's essentially what we're figuring out. How many she has now, how many she has left. Different ways of saying the same things. That's why we can't rely too heavily on keywords, because if we're looking for how much is left, wasn't there on that one. All right, this is a case where I could use 40, but I'm going to use 20 because it's smaller, right? 10, 20, 4, 8, 12, 16, 20. So this is times 2, which is 6, times 5, which is 15. I cannot do 6 minus 15, so I need to borrow or regroup. That becomes 3. I'm adding on 20 20ths. So now I have 26 20ths. And I can subtract 15 20ths and get 11 20ths. 3 minus 2 is 1. All right, hopefully that went well. If you still have questions, you still need help, I am more than happy to help you out. Good luck.